Welcome. So in this video, we're going to do further exercises using Altair to visualize and transform data. So the purpose of this exercise is to practice some of the basic visualizations that we can do with Altair. So using a package like Altair that uses the grammar of graphics, we need to think about how we want to express our data using different marks and mapping variables to different encoding channels, and also specifying some further parameters to produce the visualization that we would like to produce. Now in this exercise, we're going to transform the data using pandas and then using Altair to visualize. Altair also provides some capacities for data aggregation and data transformation. So many often it's not really needed to use pandas to aggregate the data. We can do that using Altair, which is the purpose of the second exercise. So what we're going to do now, we're going to use Altair to produce visualizations, but we need to think about the series of transformation we need to do before that visualization can be produced. The dataset we would like to work on is the Titanic dataset, which is basically data about passengers of the Titanic, and the most important variable that analysts look at is survived, and the question is what kind of affected the chance of surviving the Titanic. There are also other variables of interest, such as the passenger class, the sex, age, sibling on board, patriarch on board, fare embarked, class, and so on and so forth. Okay, so let's take a look at some of these questions. And in each one of these questions, the notebook is already giving us a starting point by transforming the data using pandas, and then we need to look at ways to visualize this data. So the first question is, how did survival depend on sex and class? So what we're doing in here, we're basically grouping by sex and class and then pulling survived and then doing the sum. So this basically will give us the number of passengers that survived in each category, sex and class. We unstack the data so that we can see it in a table rather than in a series format. And if one looks here, it looks like female in the first class. There were more survivors in that category compared to other categories. Okay, so what do we need to do here? Well, we need to visualize this data. And in this step, we need to think about what we want to produce. So it's useful here to grab a piece of paper and try to sketch the drawing that we want to produce before starting trying to express it in Altair. And that's how a package like Altair is different from other packages with pre-built-in visualization, different types of visualizations. Here it really depends on you understanding your data and being able to express how you want to produce that visualization. All right, so one way to visualize it is to visualize it as a scatter plot, right? Because we have two variables here, class and sex. So it probably makes sense to plot the number as a dot and then to scale the dot based on how many people in that categories were there. So my idea is to visualize it as kind of a scatter plot, but to scale the circle, the dot, based on that number here. All right, so let's see what we want to do here. First, we need to restack our data, or basically we don't want to unstack it. And the reason is that Altair uses a tidy format, a long format, in which each variable kind of corresponds to a column in the data. Here the variable sex in this format doesn't correspond to a column. It basically corresponds to an axis. There is a column per female and column per male, and I'm interested in comparing these two columns. So what I'm going to do here, I'm going to go back to the series format here, and I'm going to create a data frame from this series. So if we take a look at this data frame, we can see here that we've got ourselves a multi-index, sex and class, and then of course the column survive. What I'm going to do, because also Altair doesn't play well with the index, it only plays well with the columns, I'm going to reset the index. And now I get a data set in a long tidy format. Each variable is a column, and the index is not of importance here. Okay, so sex, class, survived. That's basically the same information laid out differently in this format here. Okay, so what I'm going to do now, I'm going to start charting the data. I'm going to create a chart from my data frame. And I'm going to mark a point or mark circle to make it a circle like rather than a hollow point. And of course, if I end up here, it's gonna get one dot, right? What I want to do here, I want to encode my X as the sex and my Y as the class. So we get now 6 dots, right? Of course, that doesn't show the relative number of survived passengers in each one of the categories. So the next step is to use another encoding channel to map survived. I can use color, but it makes sense here to use size to make these dots of different sizes, circles of different sizes. So I'm going to use size is survived. So it basically shows that there are more surviving females than male, right? It's immediate that in each one of the classes, we've got more female than male passengers. And one can also see that if you look at the female category, there were more survival in the first class compared to the second and third class. Whereas in male, it's not clear. It seems that first and third class were almost the same. Actually, if you look at the data, you can see that third class, there were more survived male passengers in the third class. Another way to visualize this data, because this is like correlating two variables, is to use a heat map. So heat map is basically trying to map each one of these observations to a block in a two-dimensional space and varying the color to show the intensity. So to create a heat map, I'm going to use mark bar because I want to visualize my data rather than a circle as a square. So a bar. And of course, if I don't specify anything, I'm going to get a square, which is mapping to all of the observations in this data frame. Let's differentiate observations now based on the Y and X. So if I do X and Y, I'm going to get 6 different bars, right? Of course, I want to make it a heat map. So what I'm going to do, I'm going to map color to survived here. And I get a heat map here. Okay, so can you see how powerful a package like this, you can create two completely different visualizations by changing how you map your variables to different encoding channels using different marks. Okay, so let's take a look at the second question. What was the distribution of passengers in different decks? So this is basically a question that asking us to plot the distribution of one variable. And the name of that plot is a histogram, right? I need to know I need to plot, because if you look at the data deck here, it's basically a series that contains ABC or not available, right? So I just want to plot the frequency of these different groups, and this is what we call a histogram. So the first thing we need to do to get to a histogram, we want to count for each one of these categories. So this is what I have done here. I grouped by deck, pulled age. You can pull any variable you wish, and then do the count. Okay. We can pull another variable if age. Let's see if age contains not a number. Probably it's not a good idea, but I'm pretty sure it should be the same if we pull survived. Slightly different because apparently age contains some missing values. So okay, let's do survived instead of age. We can see we have 15, 47, 59, 33, 32, 13, and so on. So again, the first step is to put this in a data frame, and I'm going to put this here as a data frame. Let's see what we got. We've got deck, and then we've got survived. Okay. Now again, alter doesn't play well with the indices, so we want to move deck from being an index to being a column. So there are two different ways to do it. Either to do create a new column, right? And we've got that. Or the second way to do it is to reset the index, which basically will put the index as column or columns if we have a multi-level index and give you back the default index from 0 to length -1. Either way, we get our data in a tidy format. So now let's think about putting it in a histogram, right? Again, histogram. Take a look at what a histogram is and pause for a minute if you want to think about it. All right, so basically a histogram is kind of like a bar chart where the height of the bar corresponds to the count here, right? So the height of the bar corresponding to deck A is 15, 47, and so on. So what I'm going to do, I'm going to create a chart object. I'm going to mark bar here, and I get my little square. Now I want to differentiate. So I want a bar for each deck. And now I have the option of putting the bars on the y-axis and putting them on the x-axis. So if I put them on the x-axis, which is basically how most histograms are provided, I can do x is equal to deck. So I get now a bar for each one of these categories, for each one of the decks. Of course, the same height because I haven't mapped I haven't used my second channel, which is the y. I want y to be mapped to survived. Now I get my histogram. So we can see here that most passengers, don't confuse this to be having survived because this is counting the values in survived. Okay, so this one may be deceiving a bit because this is counting, this is not summing, and survived is a binary variable. So actually, I'm going to rename this. So speaking about a good visualization, names have to make sense. I'm going to do deck, probably with capital D now. And then passengers. Okay, so I just renamed this and I'm going to do deck and passengers here. All right, so most passengers in the Titanic were in B and C. Okay, and then D and E. Now, of course, if you want to ask yourself how many people survived per deck, then instead of count, do a sum, because survived is a binary variable. So if we do this, and let's call this survived. Let's take out this one is not needed. Right, you can see that most surviving passengers were in B, C, and D, E, right? Not a lot in A, and not a lot in F and G. Though this may depend on how many passengers ended up in each one of these decks. So it probably makes sense to take a mean here. That's the percentage passengers surviving in each deck. So we can see that 46% of deck A passenger survived compared to B, which is 74, D 75, and E. So B, D, and E passengers had the most likelihood of surviving. Okay, and of course, once you do that transformation, it's easy to visualize it using Altair. Okay, so the point in here is to kind of really interpret the figure after visualization after creating it. Let's do this. Okay. And also questioning yourself about the validity of these visualizations. Here the issue is that the number of the passenger may not correct. I mean, we may have anyhow more passengers in a certain deck, so it probably makes sense when do the surviving to normalize to divide over the total number of passengers per deck. All right, so how does deck correlate, or does deck correlate with class? So we would like to see if passengers distribution in decks corresponded to the class of their ticket, first, second, and third class passengers. So of course we can do a count here, right? If you take the n stack, this will give you the row count here, okay? And unsurprisingly, you can see that first class passengers were placed mostly in higher decks, A, B, C, and then second was in D and E, and then the third class passenger in E, F, and G, right? So presumably the Titanic started putting passengers in deck based on the class. Higher decks corresponded to higher classes. Okay, and that's basically unstacking it. The fill in A, because some combinations are not found in the data, you will end up getting not a number, and I just wanted it to be 0. All right, so in this case, we can do a bar plot, we can do a heat map. So let's do a heat map and then do a stacked bar plot to express the data in different ways. So let's go back to the original aggregation. I'm going to call this one, let's do survived again, because some age values were missing. Probably it makes sense to benefit from survived. Get probably different, slightly higher numbers here. Okay, so the difference between 12 and 13, if you do age, is probably because 3 passengers in first A class, we did not have their age. So it's a missing value since it's dropped from the aggregate. So what I'm going to do, again, I'm going to create a data frame because Altair requires data frames. So I'm going to create a data frame from the series. Same what I have done above, I'm going to unstack, not unstack, reset the index. Okay. And I'm going to change the columns to deck class and passengers. Just giving them more meaningful names, and this is what we have. Okay, so that's the data in a long format. Once again, this is a transformation which you can do within Altair, as we will see in the next exercise. Right now, because we don't know transformations in Altair, we can do it in Pandas, which is perfectly fine. All right, so let's do a heat map. Heat map should be pretty easy now because we have done it above. Again, you can pause and try to do it on your own. I'm going to create the chart object from my data. I'm going to mark bar, okay, and then I'm going to encode the x and y based on the 2 variables here. X is going to be deck, and my y is going to be the class, right? And finally, I'm going to map my color to be passengers. So here is my heat map. And it shows that most passengers in the first class were in B and C, some of them in A, but probably the size of the deck is smaller anyhow. Second and the third class passengers here, okay? Of course, it's possible to do that correlation, the scatter plot. I can do mark point or mark circle, and I can do size instead of color, and I get that kind of scatter plot here. All right, I'm going to express this as stack charts, as a stacked bar chart. So what I'm going to do here, instead of using Y, so I'm going to use X here as deck and Y as a class. I'm going to do color here. So basically this is kind of creating a bar and stacking them compared to stacking them one on top of each other. So what I want to do here, I want to create a stacked bar chart in which each bar contains the total number of passengers per deck, and the color and the different colors of these bar corresponds to the passengers in the different positions in this bar. So what I'm going to do here, I'm going to create first my bar chart. X is equal to deck. Now I want to my Y to be the total number of passengers. So the total number of passengers is obviously passengers. Okay. The problem here, which we have seen before, is that it's stacking the bars on top of each other. So here we've got the maximum number of passenger, and we don't know where this maximum coming from which one of these classes. So I'm going to use my color to be class, and alter by default is going to unstack, stack these stack these bars based on the different number of classes. So what we have got here, we've got the number, the height corresponds to the number of passengers. So we can see that passengers in the first class, blue here, they were in A, B, C, D, and some of them in E. If you move to the second class, the passengers are in D, E, F, and then if you move to the third class, the passengers are in E, F, and G. Okay, and this again shows that most passengers in the Titanic were actually first class passengers. I mean, this is not surprising, knowing that the ship was kind of like a high-end ocean liner, but some passengers nonetheless were second and third class passengers and ended up in the lower decks. The last question is, did survival depend on deck? So what I have done here, I did a group by and did survive and this did sum, and this basically giving me the number of passengers who survived in each one of these decks. I can do mean, knowing that survived is a binary variable, and this gives me the percentage of passengers who survived in each deck. It looks, just looking at this data, which we looked at above, that deck A, deck D, and deck E passengers had most likelihood of surviving. Okay, so how do we visualize this? A bar plot maybe can be one way to do it. We can create a bar corresponding to each one of these decks to show in the different probability as a height. We can do a dot, we can do a line plot. Basically, we want to put these positions relative to each other on the same axis. All right, so this is easy. What I'm going to do, I'm going to create my data frame again. That's my data frame. And let's look at the data frame. Survived. Now it's survived. It's the average survived. So I'm going to keep the columns as they are. And I'm just going to reset the index. And here's my tidy data frame. Now I'm going to create the chart. I can do mark point. Put the deck on the X. I can put it like put the deck on, sorry, on the X and put survived on the Y. And of course, the higher the point is, the more likelihood of survival. This one is okay, it's not great anyhow because you don't know what these points, how these points are related. So of course, making it a bar chart is more useful here because filling this void here allows us to easily compare the differences in the height. The other one is to use markline, and connecting the dots is basically giving us a line, and we can see immediately the peaks here, right? There is a peak here, which is telling us that passengers in deck B and D had the highest likelihood of survival. Okay, or we can make area. Again, this is something that takes, if you don't have a preconceived visual that you want to produce, it takes some kind of a trial and an error to get to what you want to express in this data. All right, so we have visualized different queries here, basically to get an understanding of passengers in the Titanic, their demographics, and the probabilities of survival. In the next exercise, we're going to use the transformation capabilities in Altair to answer the same question.